In 1,000,000,000 years, humans could be living in a universe without any other galaxies. And the strangest thing is that they will never know that there were once billions of them. Sounds incredible? Then try to imagine this. And no, this is not about your internet connection going down. At first, you would think that the telescopes were broken, but the problem would not be with them. The problem would be with the universe itself. Sounds like science fiction? You probably thought I'd watched too many science fiction movies. Unfortunately, this time it's not the screenwriters who are speaking, it's the astronomers. And according to them, this is exactly what our universe might look like one day. Future civilizations could live in a universe where they won't see a single other galaxy. They won't have any evidence that the Big Bang ever happened. They might sincerely believe that their galaxy is the entire universe. How can billions of galaxies disappear? And no, it's not some David Copperfield trick. Will they be destroyed? Or will they just disappear from our view?
Today, we're going to travel into the incredibly distant future, trillions of years into the future, and find out why the universe itself is slowly erasing its own history. But before we embark on this journey, don't forget to like and grab a cup of coffee. Trust me, by the end of this video, you'll look at the universe in a completely different way. And why did I ask for coffee? You'll find out at the last minute.
Chapter 1. Why are galaxies disappearing? Okay, but how can billions of galaxies disappear? They're not light bulbs that someone just turns off. Galaxies don't explode, evaporate, or disappear behind giant cosmic clouds. In fact, most of them will continue to exist. We'll just one day not see them anymore. To understand why this will happen, we need to go back almost a century to when people first realized that the universe itself was not static. In 1929, astronomer Edwin Hubble made a discovery that fundamentally changed our understanding of the cosmos. While observing distant galaxies, he noticed a strange pattern. Almost all of them were moving away from us. And the farther away a galaxy was, the faster it was moving away. At first glance, it might seem that we are at the very center of the universe and that everything is moving away from us. But that is not the case. If you were in any other galaxy, you would see exactly the same picture. All the other galaxies are moving away from you. How is this possible? The answer lies in one of the most commonly misunderstood properties of the universe. It is not the galaxies themselves that are moving, it is the space between them that is expanding. Imagine a balloon with dots drawn on it. When you blow up the balloon, the dots themselves do not move, but the distances between them increase. Our universe behaves similarly, not because galaxies are running away, but because space itself is constantly expanding. And here begins the strangest part of the story. For a long time, scientists thought that this expansion should be slowed down by gravity. But the universe had completely different plans. Chapter 2. The universe broke all the rules. If the universe is expanding, it seems logical to assume that this expansion should be slowing down. After all, every galaxy has mass, and mass means gravity, and gravity is pulling. Grab a coffee, and let's move on. Don't get carried away. No commercials today. Imagine a ball thrown up. At first, it rises quickly, but the Earth's gravity slows it down more and more until it finally stops and starts falling back. For a long time, astronomers thought that the entire universe behaved similarly. After the Big Bang, it began to expand, but gravity should have gradually slowed that expansion. There was only one question: when will this process stop? But scientists decided not to speculate, but to check. In the 1980s and early 1990s, they began observing some of the most spectacular phenomena in the universe, the explosions of distant stars called supernovae. These supernovae have become like cosmic beacons. Because scientists can calculate their true brightness, they allow us to measure the enormous distances between galaxies. Can you imagine? We look at the explosions of stars that happened billions of years ago, and from their light, we try to understand how the universe itself behaves.
But the results made astronomers question almost everything they thought they knew. Instead of the universe's expansion slowing down, they saw the exact opposite. Not only was the universe not slowing down, it was actually expanding faster and faster. Now, that was a real surprise. One that probably made scientists double-check all their calculations and their coffee cups. It was so unexpected that at first, many scientists were convinced that there must be a mistake somewhere. They checked telescopes, calculations, measurement methods, and every possible assumption. But the more data was collected, the clearer one thing became. There was no mistake. Something was working against gravity. Something was pushing the universe to expand faster and faster. And the worst part was that no one knew what it was.
Since scientists didn't know what caused this phenomenon, they gave it a simple name: dark energy. Brr, it sounds like they've got it all figured out, but the truth is something else entirely. This name isn't the answer. It's just a reminder that we've come face to face with one of the universe's greatest mysteries. Today, dark energy is thought to make up about 70% of the total energy in the universe. In other words, much of what drives the universe is still a complete mystery to us.
Chapter 3: When Light Loses the Race with the Universe. Imagine the most powerful space telescope possible, bigger than anything humanity has ever built. A telescope that can see almost to the beginning of the universe. It seems impossible that something could remain invisible. After all, light travels as fast as nature allows, nearly 186,000 miles per second. But the universe has one rule that changes everything. Sometimes the problem isn't that light is too slow. The problem is that the space between us and the distant galaxies can expand faster than light can cover that distance. Sound impossible? Imagine a runner on an expanding track. He can run very fast, but if the track under his feet gets longer and longer, the finish line gets farther and farther away.
Today, we can still see billions of galaxies because their light began its journey millions or even billions of years ago. We see them not as they are now, but as they were in the distant past. In fact, every look at the sky is a look into the past. When we look at the sun, we see it as it was about 8 minutes ago. When we look at distant galaxies, we see their past billions of years ago. But in the future, the situation will change.
As the universe's expansion accelerates, more and more galaxies will cross a threshold beyond which their light will never reach us again. They won't be destroyed. They will simply become forever inaccessible to our observations. Think about it. A galaxy could be exactly where it always was. Its stars could still be burning, its planets could still be spinning in their orbits. But to us, it would be as if erased from the map of the universe. This is called the cosmic horizon, the invisible boundary that separates what we can still see from what will forever remain beyond our reach. And here comes one of the strangest consequences. A civilization living in the future might look up at the sky and see almost nothing but its own galaxy. They'd be living in a universe that would seem much smaller, emptier, and more mysterious than the one we see today.
But the most surprising thing is yet to come. Because that civilization of the future might not only not see other galaxies, it might not even know they ever existed.
Chapter 4. A civilization that will live in a lonely universe.
Imagine an astronomer living in the distant future. Their civilization is advanced. They have giant telescopes, far more powerful than anything we can imagine today. They look to the sky in the hope of finding answers about the universe. But they are met with a strange discovery. Wherever they look, they see almost nothing. There are no distant galaxies. There are no vast cosmic structures. There is no light to tell the story of the universe's billion-year history.
Their sky will look very different from ours. Today, when we look up at the night sky, we see more than just stars. We see evidence that the universe has a history. We can observe distant galaxies, which show that the universe was once much hotter and denser. We can study the cosmic microwave background radiation, a faint glow left over from the early universe. But a future civilization may not have this opportunity. They may look up at the sky and see only their own galaxy, a vast island in the infinite darkness. To them, it may seem that the universe has always been like this. One galaxy, one cosmic island, nothing more. And therein lies one of the strangest ironies of cosmology. The older the universe gets, the harder it can be to understand its past. We live in a very special moment, not because we are at the center of the universe, we are not, but because we live in a time when we can still see far enough back to reconstruct cosmic history. Our telescopes today are like time machines. They allow us to look back to when the universe was young. But in the future, this window may close. In trillions of years, astronomers may have less evidence for the beginning of the universe than we have today. They may not even know that billions of other galaxies once existed. And that leads to one of the biggest questions. Is it possible for future scientists to live in a universe where the universe itself hides its past? Chapter 5. A universe that will hide its beginning. When we look at the universe today, we see traces of its past. Our telescopes are not just windows into the distant cosmos. They are time machines. The further we look, the older the universe becomes. We can observe the first galaxies. We can measure the expansion of the universe. We can detect faint radiation that has been traveling through space for almost 13.8 billion years. This is the cosmic microwave background radiation, one of the most important pieces of evidence that the universe was once incredibly hot and dense. It is like the oldest memory of the universe. It is like a light imprint from its childhood. However, in the future, this memory may be lost. As galaxies move beyond the cosmic horizon, their light will no longer reach future observers. The cosmic microwave background radiation will also become fainter and more stretched due to the expansion of the universe. However, in the future, this memory may be lost. As galaxies move beyond the cosmic horizon, their light will no longer reach future observers. The cosmic microwave background radiation will also become fainter and more stretched due to the expansion of the universe. Trillions of years later, advanced astronomers may look up at the sky and see no sign of the beginning of the universe. They might not see other galaxies. They might not see traces of the Big Bang. They might have no obvious evidence that their universe ever had a beginning. Their scientists could build theories about their universe based on what they see. And that would mean that the cosmos they see would tell a very different story.
They might think that their galaxy has always existed. They might think that the universe is much smaller and simpler than we know it today. And therein lies one of the most amazing lessons of the cosmos.
The truth about the universe is not forever visible. Sometimes you have to be in the right place at the right time to discover it. We live in a time when the universe is still showing us its past. We are among the first beings to look up at the sky and understand where it all came from. But one question remains. If a future civilization could no longer see the beginning of the universe, would it ever believe that it existed?
Chapter 6. We live in a special moment in the universe.
When we look at the night sky, we often think we are seeing an eternal picture. The stars appear unchanged. Galaxies seem like immobile cosmic cities that have existed forever. But in reality, we are only seeing a brief moment in the history of the universe. The universe is not a static picture. It was born, it has changed, and it is still changing. Galaxies are receding. Stars are born and die. The cosmic scene we see today will never be repeated. We are not living too early and not too late.
So, why did I ask you to get a coffee at the beginning? Not because there was a long video waiting, but because I wanted you to stop for a few minutes and look at the universe in a different way. Because what we learned today is not just a story about disappearing galaxies. It's the story of an incredibly brief moment in the history of the universe. A moment when we can see and understand the cosmos. Trillions of years from now, other civilizations may look up at the sky and not see what we see today. They may never know that billions of other galaxies once existed.